Good morning, everybody. John Belk with Intelligent Concrete, Director of R&D. Sorry for the absence. Thanks for all the folks out there who've been asking us to make videos. We've been working on a lot of projects, and unfortunately, things fell off the plate, and this was one of them. But we've got some exciting things coming out in 2018 here, some books, some other projects that we've been working on. So stay tuned for that. But this is for my buddy Victor on LinkedIn. He asked a basic but fairly tough question to answer. Basic question with a tough answer. You know, what is a good dosage for high-range polycarboxylate style water reducers? And first, those are defined as water reducers that can reduce the amount of water needed to keep or maintain slump, and normally it's around 35% reduction in water, plus or minus. And polycarboxylate style means that we're not necessarily changing up the pH of the solution. We're acting off of steric repulsion, where something, polycarboxylate cone polymer, adsorbs to the cement particle surface, and through steric repulsion gives us that flowability with a little bit of water. So, Victor, to answer your question, dosage is dependent really on two things. One, the cement type. And what I mean by that is not all cements work, or cementitious binder packages work with the high-range water reducer. So make sure you're working with your salesperson in your local area who knows your cements and can pair you up with the type of polycarboxylate high-range water reducer you need. And bear in mind, we're not just using polycarboxylates. High-range water reducers are packages. It's got water, food coloring, your polycarboxylate wax, or whatever they're using, melamine, or as well as a defoaming package, a sugar, a salt, a whole bunch of other bells and whistles. The other piece of that is your dosage is going to depend on concrete type. Are you doing a self-consolidating concrete? Are you doing a flow fill? Are you doing a wall mix? Are you doing a pavement mix? Of course, for some of those mixes, you don't necessarily have to use a high-range water reducer. But let's for a second assume that we're using an SCC. So for an SCC, I'm just going to throw a mix design out there. Feel free to use this. I would definitely play with the numbers. I'm just throwing it out there. 650 to 720 pounds total cementitious. Throw ash in there if you'd like. 1,250 pounds per cubic yard of your sand. 1,350 pounds per cubic yard of your rock. And that's a 3/4, 6757. So a 3/4 maximum sized aggregate. Then another 300 pounds of a pea gravel, a 3/8. With a water cementitious of around 0.35 to 0.38, and we're talking about a higher strength mix here, since it is, normally with SCCs, you also get that. Air and training package, let's assume we're in Colorado or Michigan, 1/2 ounce to 1 ounce per hundredweight. If we're in Hawaii or a place that doesn't have severe freeze-thaw, just take that out and add another ounce or two of your high range. So for the high range, I would say somewhere between 6 and 8 ounces per hundredweight. I've used as high as 10 for some SCCs, and then for really high performance stuff where we had a cocktail of additives in there, I think we even went up to like 12 or 14 or even 15 ounces per hundredweight, but that's a very special occurrence. So anyway, I hope that answered your question. If you have any questions, just shoot us a direct message or just throw a question down on this video here that we're going to be posting. Thanks again very much for folks out there who are very had a lot of positive things to say. We got some great messages out there from folks about the impact that our videos were having. So we're going to try to do this coffee talk in the morning, right before the workday starts. And if you have any questions, if not, we're just going to throw ideas out there, really just try to educate the industry. And again, if you ever have any questions, don't hesitate to ask. Go concrete, beat asphalt.